Today we're going to work on factoring quadratic trinomials, which looks something like this. Ax squared plus bx plus c. A, b, and c are just numbers. If any of these numbers, well, if a or b is 1, it'll look like there's not a number there. So remember, hidden ones do exist. If the c was a 1, you would see it. So, process we're going to follow here starts off a little bit different than what we've been doing, but then we use the factoring by grouping, which uses GCF factoring. And so we're going to start off a little differently, but then use some concepts we've already talked about. There are some things that I will show you here that are optional when you go to do these on your own. I tend to write a lot to keep myself organized because I get sidetracked. But if there are steps that you feel comfortable skipping writing, I will let you know what those steps are when we get there. So the first thing I like to do is label what A, B, and C are, because that's going to be important for what we're doing here. A is the number in front of x squared. For this first one, we don't see a number there, so it's a hidden 1. B is the number in front of regular x. C is just the number term at the end. The very first thing we are going to do is we are going to multiply the A number times the C number, just the coefficients, not the variable. So A times C is going to be 1 times 42, which is 42. And then everything I'm writing here in this big X that I have is optional. It's just to help you keep organized. If you're a rock star and you don't need to write all this extra junk down, you don't need to write it, and I'll remind you again when we're done with the problem. But this helps us keep organized. If you like using this, great, use it. With the big X, it's just, like I said, to keep us organized. What you're going to write in the top section is whatever A times C was, which we know is 42. In the bottom section, we're going to write the number for B, which is negative 13. We are going to be looking for the two numbers that add up, or sorry, not add up, that multiply together to give us our A times C number, but add up to give us our B number. So how can I get to 42 by multiplying? I can do 1 times 42, I can do 2 times 21, I can do 3 times 14, and I can do 6 times 7. So, out of these numbers, I need to pick one of these pairs to where I multiply and I get positive 42, I add and I get negative 13. The only way that can work is if I use 6 and 7, but in order to get a negative 13, it needs to be a negative 6 and a negative 7. I'm going to erase this. So then what we do from here is instead of writing this as a trinomial, I'm going to rewrite this as 4 terms. I'm going to take that B term and split it up into these two numbers. So instead of negative 13x, it's going to be negative 6x and negative 7x. So x squared stays the same. Instead of negative 13x, I'm going to do negative 6x, negative 7x. If I combine those like terms, I get negative 13 since they're equivalent, that's allowed. And then I keep the C number 42 the same. Why did I do all that? Well, this now looks like 4 terms. We know when we have 4 terms, we can factor by grouping. So, just like we did in the last lesson. GCF of x squared and negative 6x is x. When I factor out that GCF of x squared divided by x is x. Negative 6x divided by x is negative 6. Now I'm going to do the same thing with the second half. It is a negative number here, so it's going to be a negative GCF. The biggest number I can divide both 7 and 42 by is 7, so my GCF is a negative 7. Negative 7x divided by negative 7 is just positive x. 42 divided by negative 7 is negative 6. And then we're going to finish this off exactly like we did with factoring by grouping. One set of parentheses is going to be my 2 GCFs, x minus 7. The other set of parentheses is going to be x minus 6. So this right here is my final answer. If I were to double distribute, I would end up back with what I started with, which means I know I've done things right. I'm not going to show you that in the interest of time, but you could check that on your own if you would like. So let's talk about a few things before we do the next problem, just because there was kind of a lot going on there. Once you figure out what these two numbers are, and you set it up as 4 terms, it's exactly factoring by grouping. So that's why we did that last lesson to get us ready for this. Also, like I said, if you're a rock star, you're super organized, you don't get sidetracked like me and forget what you're doing halfway through a problem, you do not need to write this X stuff. This is just to keep you organized. What I do want to see is your factoring, and I want to see a little bit of your work for how you get there. I do not need to see this, but like I said, if it helps you, do it. If it's too much, you can do it without it, skip it. I'm going to show this for every problem just so you see where things are coming from. This right here is your final answer, like I said. Let's try a few more. Nothing gets any different. It's going to be the same process every time. And I will not give you any numbers where your AC is going to be larger than 100. So you don't have to worry about doing like giant 3-digit or 4-digit numbers. So let's try another one. So for this problem, A is 3, it's a hidden 1 in front for B, and C is negative 24. A times C is going to be 3 times negative 24, which is negative 72. So I'm looking for two numbers that multiply together to give me negative 72 and add together to give me my B number, which is 1. So I will put a factoring sheet on Canvas that has all of your factors of numbers between 1 and 100. If you're not a super great rock star, that's okay. A lot of people aren't. So how can I get to 72 by multiplying? I can do 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. So we need to pick one of these pairs of factors, make it to where we get a negative 72. To get a negative 72, I need one positive, one negative, and they need to add up to 1. The only way that will happen is if I do a negative 8 and a positive 9, because negative 8 plus 9 is positive 1. So my two numbers are negative 8, positive 9. So where do I go from here once I have the two numbers? We write it as 4 terms. And once we have it written as 4 terms, it's something we've done before, that factoring by grouping. So when I write it as 4 terms, 3m squared stays the same. Instead of 1m, I'm going to do negative 8m plus 9m using those two numbers I came up with. Minus 24 stays the same. Now I just factor by grouping, which we've done before, so that's not too bad. GCF of the beginning, the biggest number I can divide 3 and 8 by is 1, so we're going to ignore that for now. We could write a 1 coefficient, we don't have to. Biggest factor of m I can pull out of both of those is m. So when I factor out my GCF, 3m squared divided by m is 3m. Negative 8m divided by m is just negative 8. Second half is a plus sign here, so we have positive GCF. The GCF of 9 and 24 is 3. 9m divided by 3 is 3m. Negative 24 divided by 3 is negative 8. Double check here, do I get the same thing in both sets of parentheses? I do. We can factor by grouping, not a problem. So our final answer is going to be our two GCFs, m plus 3. It's a little smudgy there, sorry. And then our repeated factor, 3m minus 8. If you would have paused the video and worked ahead on this problem on your own and then checked back in, there is a different way you can do things in the middle, but you'll still end up with the same answer. What I mean is if I switch these two numbers and I do 9m first and then negative 8m here, I'll end up with different GCFs here, and that means I'll have different repeated stuff here, but these should still match and your final answer should still look the same. Remember that this is the same as 3m minus 8 times m plus 3. So as long as you have the right things, the order is not super important. It'll all work out in the end. Let's try a couple more. For this next one, A is 2, B is 11, C is 5. A times C is 2 times 5, which is 10. So I'm going to be looking for numbers that multiply together to give me 10, but add up to my B number, which is 11. How can I get to 10 by multiplying? I can do 1 times 10. I can do 2 times 5. And that's it. So this one we don't have to think about too much here. The only way I can get my numbers to multiply to 10, but add up to 11 is if I use positive 1 and positive 10. So then that means this 11r is going to turn into 1r and 10r. So rewrite this as 4 terms. 2r squared plus 1r plus 10r plus 5. Factor by grouping. The GCF of 2 and 1 is 1. We don't have to write that coefficient. You can if you want. GCF r squared and r is just r. When I factor out the GCF r, when I divide, I get 2r plus 1. Now for the second half, GCF here, GCF of 5 and 10 is just 5. It's a positive sign, so we have a plus sign in front here. 10 divided by 5 is 2r. 10r divided by 5 is 2r. 5 divided by 5 is 1. Do these match? Yes, they do. Good. We can write our final answer using factoring by grouping. Final answer is r plus 5 times 2r plus 1. Again, like I said, if you want to check your work, double distribute this out. You should get back what you started with, as long as you did everything correctly. One last one. So, this time, A is a hidden 1, B is 9, C is 8. A times C is going to be 1 times 8, which is just 8. So we are looking for two numbers that multiply together give us 8, add together to give our B number, which is 9. So how can we get to 8 by multiplying? I can do 1 times 8, I can do 2 times 4, and that's it. So, the only way I can get a pair of these numbers to add up to 9 would be if I do positive 1, positive 8. For some reason, when there's a 1 involved, people often get confused. Don't let that throw you off. Think about how you can get to your numbers, and like I said, I'll give you a factoring sheet to help you with that too if it's not your best. All right, let's rewrite it as 4 terms. N squared stays the same. If you want to write that 1 in front, you can. Instead of 9n, I'm going to do 1n plus 8n. And then plus 8 stays the same. Factor by grouping. GCF of n squared and 1n is just n. When I divide by n, I get n plus 1. GCF of 8n and n is 8. Positive because there's a plus sign here. 8n divided by 8 is n. 8 divided by 8 is 1. So then, last but not least, we write our answer as 2 binomials. N plus 8 goes in one of the sets of parentheses. Repeated factor n plus 1 goes in the other. So that is it for factoring quadratic trinomials. It involves that factoring by grouping with one extra step that we did beforehand. We'll also use this to solve equations in the next lesson. Have a great day.